Hi everyone, my name is Sam and welcome to my Next Gen AI Guy YouTube channel. In this video, we will going to learn that how to convert speech to text and we will do analysis on that text. We also see that how to do the speaker diarization, how does it work and how to implement with the help of Python code. Also, I am going to show you that how to do speaker identification with the help of Python code. So before jumping to the practical and theoretical explanation, let me give you the demo of this project. So that's how our project is going to look like. This is the UI of our project. In this demo, I will show you that how to use this UI. I will also going to explain you in depthly that how to build such kind of speech to text analysis project. So let's start. On the left hand side, you are able to see that options. Either you can upload your audio file or you can choose the default one. So I will choose the default one. Just click on it and it has started running over here. So it is taking 2 minutes to convert speech to text and do speaker diarization plus speaker identification. After that, on the extracted text, we are analyzing like sentiment analysis, topic detection we are doing with the help of LLM plus feedback generation. We are getting the feedback with the help of LLM model. Okay, so code runs successfully and it is able to generate it has converted speech to text that we will going to see in the CSV file. So in that audio I have added my own audio as well as, so we are able to see that this conversation is speak by me and the speaker it is able to analyze over here. So as you can see that it is able to recognize the Sam. So it is successfully able to do the speaker diarization plus speaker identification. We are able to see that this is the start and end, means from where to where that person have spoken in that audio file, and here we are getting the text what he have spoken. That audio has been converted into a text, and next column we are getting a speaker name. In this case we can see that three speakers are there. One is me, Sam, and the other is speaker 2 and speaker 3. So next we have did the speaker sentiment analysis based on the text. So it is able to categorize in these three things: positive, neutral or negative. So with respect to each speaker you are able to see that the sentiment analysis. Next is the conversation review, which is generated with the help of LLM. We have given the LLM the instruction plus this text. Based on that it is able to generate the feedback for this all three speakers. So here it has detected the topic which they were talking and the sentiment also. So I have already shown you the sentiment analysis. The LLM is also has generated the sentiment of that person whatever the speaker has spoken. Based on that it has generated the feedback also. We are able to see with respect to speaker 2, speaker 3 and the speaker 1, which is Sam. So that was the demo of speech to text project. I will going to show you in the Python code how does it works and each and every terminology which we have used in this project. I have also given GitHub link in the description. If you guys are new to this channel, please like and subscribe for more such videos. So before jumping to the code part, let me explain you terminology which we have used in this project. So first is speaker diarization. What is speaker diarization? Main objective of speaker diarization is to finding out who spoke when was that person has spoken in that whole conversation. So finding out who speak when. So that was the objective of speaker diarization. It is not going to give the name of that person. It will going to say that speaker 1, speaker 2, speaker 3, like that. It will going to make a cluster of that unique speaker. And in case of speaker identification means identifying who spoke by matching the unknown speaker with the known speaker. So that we called as a speaker identification. So in this project we have used a WhisperX, which is built by OpenAI. This is the tool which we are utilizing to convert speech to text plus do the speaker diarization with the help of WhisperX. So first I will going to explain you that what is the WhisperX, how does it work. As we can see that it is ASR, means automatic speech recognition system with the word level timestamping and speaker diarization. WhisperX is an advanced model of Whisper. So Whisper what exactly does, it converts speech to text only. In case of WhisperX, it will do speech to text as well as plus speaker diarization to identify who spoke when. So in the below you will see that the Python code which I have used in my code. So I will going to explain you that what exactly it is and how does it work. So first we are importing the WhisperX for a speech to text plus speech diarization process. So here we have given the device is equal to CUDA audio file and batch size plus compute type. So in case if you don't have a GPU, then you just need to change this CUDA to CPU and float 16 to int 8. After that, if you will run, then it will run in your CPU as well. So here what we are doing, here we are importing the model with the help of whisperx.load model. In this case, we are importing large v2, and here we have passed our device, which is CUDA. In case CPU, that will be passed over there. Compute type is a float 16. Next, we are just loading the audio file with the help of whisperx.load audio, and here we have passed the audio file which is given over here. You just need to replace this audio file with your own audio file, and after that we are just transcribe with the help of model, which model we have loaded over here. Next, we are printing the result segment. So that result we will going to pass in this whisper load align model. In this one, we are passing the language which is detected during the transcribing that audio. That language we will going to pass over there, and based on that the model A plus metadata will be generated. The next result we are getting with the help of WhisperX align. Here we have passed the result segment and we have passed the model with respect to this language, and next we are passing the audio file. So after that we are just printing the result segment. Next is the diarization pipeline, which is the most important one, which allows us to identify who spoke when. For that, we just need Hugging Face authentication token. You can go to the huggingface.com. Over there, go to the setting and generate a API key. That API key you can paste over here, or you can paste into the .env file after cloning the GitHub repository. So this one, what it will going to do, it will going to identify who speak when. It will just going to create a cluster of speaker. So finally we are printing the result segment, which will contain start and text and speaker. So who speak when, which I have shown you in the demo. So that was the way to do that. I will show you that code in the VS Code as well as. So we are using LLM from the Groq. So Groq is a platform which provides us the API key to access the LLM model. LLM model is a large language model, means it's just a language model which is used to predict the next word of the sentence. But why we call it as a large language model? Because it has been trained on a large amount of data or huge amount of data. So to access this LLM from this Groq, you just need to sign in. After signing in, go to the API key section and create an API key. Give the API key name and click on the submit button. It will going to generate the API key. That API key you can paste into the .env file. So now let's just move to the coding part. So now we will see that how to implement that speech to text project in this VS Code. So this is the main file which is required to run this project. In this we are using Streamlit to create a framework plus user interface. So here is the audio file. In this audio folder we have all the audios. In the UI we have seen that two options were there, either to use default one or you can upload the audio file. That uploaded audio file stored over here. And next we are having .env file where we will going to store our credential. This is the Hugging Face token and the Groq API key. Don't worry about it, I will going to delete after this project. Next we are having app.py file, which I have told you. This is the audio to text module which allows us to convert speech to text, plus we are doing speaker diarization with the help of this audio to text module. Next we are having concat audios. I will going to explain you all the modules in depthly. First let's see overview of all the module. This we have used to just combine one or more audios. You can do that over here. So we are having a feedback generation. This we are using to generate a feedback based on the text plus speaker. So that is used to generate the feedback with the help of LLM model. So next is the main.py file where we are combining the whole modules. It's audio transcribe, sentiment analysis or speaker name mapper. That module I have loaded over here. In that we just need to pass the audio file. Based on that it will going to generate the final answer. Next we are having requirement.txt file which I will going to share you with all. Next we are having a sentiment analysis which we are doing with the help of Vader. Here we are having a speaker identification. So let's go first with the audio to text. So I have already explained you from that WhisperX GitHub repo. That same one I am using over here. It has just little bit change. We have just created that into a class and function, so we can import it. So first what we are doing, first we are importing the WhisperX. Main idea of the WhisperX to do speaker diarization. Next we are importing the pandas. After that, this is the warnings. Sometimes what happens when you run the project, it will give some future warnings unnecessary, so that one you can ignore. After that, importing a load.env file to import the credential from the .env file. So here I have created a class which name is audio transcription. I have told you that I will going to show you how to run in the CPU as well. In this case, we have given the device as a CPU and compute type is int 8. If you have a GPU, then you can replace this CPU to CUDA and this compute type to float 16, and you are ready to run your project. And here we have loading the model. So in this case we are using large v2 model. We are doing with the help of WhisperX, which we have imported over here. So we are importing a large v2 model and the device name which we have given over here. So CPU compute type is a int 8. Here also I have imported the diarization model. So for that I need a Hugging Face token which we have passed over here, and device name which I have given over here. Two models we are loading. First one is to convert speech to text. Second one is to do diarization, means finding out who spoke when. Next we are creating a transcribe audio. In this we will take the audio file, and with the help of whisperx.load audio we will going to load that audio. Here we have transcribed that audio and we have passed the audio file and the batch file. It will going to transcribe from speech to text, and after that we are loading the model based on the language. First it will going to transcribe. Over there it will definitely going to detect that what language it has been spoken, so that language we will pass over here, and the device which is CPU. So based on that model it will going to load. So here we have passed the model A, which is with respect to that particular language, metadata with respect to WhisperX, and audio which we have passed, and the device plus return character alignment. So next we are doing the diarization with the help of diarization model which we have loaded over here. So that diarization model, after loading we are passing the audio file in that diarization model, and it will going to do the diarization. With respect to that diarized segment we are passing that one and plus the result from the previous model, this one. The final result will be generated. Okay, so here we are just converting that into a data frame with the help of pandas. So we just need these columns, so that's why we have kept this one, and we are just returning that data frame. So that was for audio to text model. Next, concat I have already explained. We are doing with the help of PyDub audio segment. So audio segment provides different features also, means in case you wanted to add two mp3 audio files, that also you can do with the help of audio segment tool. After that we are combining that both audios in the wave format, and next we are saving into this audio file. So we have seen that how to convert audio to text and how to concat two audios file or three audios as much as you want. That one you can do. Next we will see sentiment analysis, how we are doing. So for the sentiment analysis I have used a Vader. What is a Vader? Vader is a pre-trained sentiment analysis model that provides a sentiment score for a given text, means whatever speech to text is converted, that text we will going to feed to the Vader model, and it will going to do the sentiment analysis on that text. First we are importing the pandas. So pandas used to handle the data frame. Next we are importing from NLTK library sentiment.vader. We are importing the sentiment intensity analyzer, which is we use to find out the either it is negative sentiment, positive or neutral. If you are running the first time, then uncomment this one, and you have to download that Vader underscore lexicon library. After that only you will be able to run this Vader sentiment analysis. So we have created a class which name is sentiment analysis. Here we are taking the data frame plus sentiment intensity analyzer. So here we have created analyze sentiment. In this one we are passing the text. It will going to use that sentiment intensity analyzer dot polarity score. So polarity score range between -1 to 1, where a minus score, that means that super negative, like words like disgusting or awful. Score 1 means the words are super positive, like excellent or best. That we are doing with the help of polarity score. So it will just going to give you -1 to 1. So what we are doing over here, we're taking the text column, and on that text column we are just applying this function. So we have created one new column which will going to store the all classification, like a positive, negative or neutral plus compound. That all result will be saved in this sentiment column. Here we are just normalizing, because in that column the data will be saved in the JSON format, so that we are normalizing and we will going to drop this sentiment column, and we will going to keep the other 4 columns, which is negative, positive and neutral. I can show you, you will get a better understanding from here. So these are the 4 columns: negative, neutral, positive plus compound. Those 4 columns, previously it was saved in the sentiment column as a JSON format that we have normalized with the help of JSON normalizer, and it has created a 4 new column with respect to the result. After doing this, we're just concatenating the self div plus sentiment div. So there are 2 terms like concat and merge. So only difference is that concat is used for concatenating data frames either horizontally or vertically. In case of merge, you need a common column or index to merge the 2 data frame. So that was the difference. That's why we have used a concat. So after that, we are just categorizing the sentiment with respect to compound. If it is above 0.05, then positive. If less than 0.05, it's negative. Other than that, it's neutral. Next, we are doing add sentiment category. So that function we will going to apply into the compound, and we have created a new column which is sentiment category, which I can show you here. So that one based on the compound column. So finally we are saving that CSV file. So main part over here is the speaker identification. So how we are doing that? Identifying the speaker is quite difficult. So what we are doing in this audio, you are able to see that this is combined audio. This is the recording of myself. Over there I have just given my introduction. My name is Sam. So that audio I am concatenating in this AI advanced, and final result is combined audio. Let me explain over here. You will get a better idea. Imagine that you have only this 3 persons audio and you know this 1 person. So that introduction you will going to add on in this 3 conversation, and it will going to cluster like this one is similar to this one. So it will going to identify speaker 1. So in this conversation, why I have added to do speaker identification, in this he have spoken about his introduction and he have mentioned his name. With the help of Python code, I will going to extract the name, and I will replace the all speaker 1, which is also going to over here, with the name of that person which he have given in the introduction. So that Sam name I will going to replace with this one and this one. That's the best way I found it, and it works really fine for me. You can try it also. So in this speaker identification, I am doing the same thing. I have given the predefined name. What it will going to look out in that conversation, that if that Sam name is present, Alice name is present, or Bob name is present, then it will going to replace with the cluster name. How we are combining it? First we are converting that name into a lower format, and we are converting the text into a lower format. Then we are checking the name, is that present in that text or not. If it is present, then we will going to return the name. That function we are optimizing over here, and one by one with respect to whatever speaker we are having, we will just going to map that speaker with the name of that identified person. So that was the way to do the speaker identification. Next we will jump to the how we are doing the feedback generation. For feedback generation, we are importing OS. Next, we are importing the chat Groq from LangChain. So we know that LangChain is a framework. We used LangChain to develop a LLM based project. After that, we are importing the load.env to import the credential from that .env file. And next we are importing the prompt template, which allows us to give the instruction or prompt to the LLM model what to do. After that, we are just importing the string output parser to parse the LLM output into a string format. Here we have created a class conversation retriever. First we are loading the .env file. Here we are passing the Groq API key, which we are loaded from that .env file. And after that, we are initiating the chat Groq by providing the temperature plus API key and name of the model, Llama 3 model, which we are using over here. In case you want to use the latest model for Llama 3.1, that name you can pass over here. And here we have given the prompt template, means in this one I have just given the, as a reviewer, what you have to do. So you have to do sentiment analysis as well as topic detection and generate the feedback based on the text plus speaker. Next we are using the prompt template. In that one we are given this template plus input variable as a conversation. Finally we are creating the chain with the help of this prompt LLM and string output parser. That chain we will going to invoke over here by passing the conversation. So this function will ask you to give the conversation. We will going to give the of that speech to text. That text we will going to pass with respect to speaker, and based on that it will going to generate the feedback. So next we will move to the main.py file. So this is the main.py file which is combining all the modules which we have written over here. We are converting speech to text. Next we are transcribing this by initiating that function, and we have passed this data frame to the sentiment analysis, and it will going to do the sentiment analysis with respect to text, and it will going to create more columns like negative, neutral, positive or compound. Here we have initiated that sentiment analysis and we are saving into a user underscore sentiment.csv. If you don't want to, then you can skip that part. And after that we are just passing that data frame to a speaker name mapper, where I have shown you how to identify the speaker. Finally, we are returning the final df, which we will going to show in the UI. If you just wanted to run the main.py file, that also you can do. For the case of UI that I have created with the help of Streamlit, it's easy to use. If you don't know how to use it, then you can add to ChatGPT. It will going to create a code. So first we are importing the Streamlit, next we are importing the pandas and operating system Seaborn, just to visualize that sentiment analysis means negative, positive or neutral with respect to speaker. Here we have used the matplotlib also to create a chart. In the main file we are importing the process audio. We will feed the audio and it will going to generate the final data frame to showcase into the UI. And here we have feedback generation. So based on that data frame we will going to create a feedback. Save uploaded file means there was two options, either to use the default one or upload. So that uploaded file will be saved with the help of this save function. This is the get conversation with respect to speaker. We have a different speakers, so with respect to speaker we will going to have a conversation. So this is the Streamlit to design our UI. So here we have just given the title. This design you can change according to your need. This is the select box. Two box we have created up, either to go with the upload box or default one. If you have choose the upload an audio file, then this function will going to run. If you use default audio, so this one is going to run. So in case of upload file, what it is doing, it will going to save that upload file in this upload directory, and from there it will load and do the pre-processing, and finally it will going to display the data frame with the help of this process audio which we have imported from this main.py file. Now if in case of default one, same process will going to happen. Rather than saving, it will take the default audio which is given over here, combined audio.web, and it will going to do the process audio which we have imported from the main.py file, and the final result will be displayed. So that was the way to build a speech to text analysis project. If you found this video informative, please like and subscribe for more such videos. Thank you.